We'll start with the first afternoon session on transportation and related issues, transporters, things and people. And Vinay, Shet, Director of Mapping at Lyft, will talk about current and future trends in mapping.
Thank you, David. I think it's fair to say that since the dawn of humanity, we have been obsessed with trying to capture the Earth's surface in a graphical form. And part of what drives that, I think, is that no amount of oral or written description can truly capture the richness of topographical data that a map captures, right? So, good afternoon, everyone. My name is Vinay Shet. I'm a Director of Product at Lyft. I'm here to talk about mapping and trying to look at where we are at right now and what has been happening in the last several years and where we're going in the future. I'm going to be talking a bit broadly about mapping than just what we do at Lyft specifically. So hopefully we'll try to cover, again, the trends within the mapping tech itself, plus also what are the applications that use mapping and how they have been pushing the forefront of mapping as well. So a little bit about myself first. So I spent about a decade or more doing core research in computer vision. I have a PhD in the field. Spent several years at Siemens Research after that, focusing on detecting objects, detecting cars, humans, and so on and so forth. Then I was a product manager at Google Maps. I was responsible for their road network and navigation data before I left. My team was one of the first teams that built out the machine learning algorithms to analyze street view and aerial imagery to actually build maps at scale. And going back in the past, I was the PM for Street View and also Recapture. Recapture, as you know, is the spam protection tool, and we launched the I'm Not a Robot thing. Presently, I'm at Lyft focused on mapping, very specifically on autonomous vehicles, like what does mapping mean in that space. And in the past, I've also been looking at the core mapping aspects of Lyft. So Lyft, as you may know, is one of the fastest growing ride-sharing companies in the United States. Today, we do on the order of around 10 million rides per week, and we cover about 95% of the US population, and we have coverage in all of the 50 states. Again, the longer-term ambition of Lyft really is to really...
What does that 95% mean?
95% of the US population has access to Lyft service. You can call a Lyft.
They downloaded the Lyft app?
No, they can. No, they live in the neighborhood. Right. So Lyft, again, the ambition of what we want to do is really be redefine transportation as a service, and in doing that, I think one of the big aspects that we want to push forward on is also work on autonomous vehicles. Right? So Lyft's approach to autonomous really is twofold. We're taking the first approach really is what we're calling the open network approach, where we have anyone out there who's developing an autonomous vehicle, any partner of ours, to bring their technology into our network, plug in, and be able to deploy that on our network. Right? That's what we're calling the open network. And again, the idea here is to democratize and accelerate the development of autonomous vehicles by providing a means for them to actually start plugging in and servicing the customers on network. The second piece is what we're calling the level 5 effort. Level 5 is our own effort where we are developing the whole tech stack for autonomous vehicles as well. And again, the idea here really is to build out our own tech stack and be able to actually deploy our own network as well. So a lot of exciting things happening here. So coming back to the mapping aspect, and you can see why mapping is so near and dear to us, because we need to really fundamentally understand the physical world so that we can operate both our core network as well as in the future into the autonomous. Now, when we talk about mapping, most of us, I think, here remember the days when we used to open up a paper map and then try and figure out a way where we are out in this and so on. Over the last decade or so, a lot has happened in the consumer space, right? We've gone essentially from having to open a paper map every day to basically having navigation on our phone with us all the time, right? To the point where we are never lost anymore, right? And so the transition really has been going, on the consumer side, has been going from paper maps to be able to actually navigate on demand wherever we want. But I think a lot more has been happening, and a lot more is going to happen in the enterprise space, in the commercial side of things. And I just wanted to touch upon a few of the areas that are actually going to really benefit a lot from mapping data, as well as be the defining technologies that actually push very specific requirements back into what mapping needs to be, so it moves the mapping area forward itself. So autonomous vehicles is an obvious one. Right? For cars to drive on physical street, they need to fundamentally understand the world in a very different way than has ever been required before. Right? So what does that entail? We'll talk about this a little bit more. Ride sharing itself, right? So for ride sharing to work, we have to match the drivers and the passengers, and both of them need to be able to specify A, where they want to go, and B, the driver needs to know how to get to this to pick up the passenger. Right? Augmented reality. This is another big area which is pushing the forefront of what it means to be doing mapping, because you need to be able to have a really strong understanding of where your device is pointed, or what is the world, the scene you're looking at. Drones and by extension flying cars. Again, we need to have a very deep understanding of what's going on around them. And people don't necessarily put this together, but just digital advertising, right? A lot's been happening in that space, and a lot more is going to happen when we have a better understanding of the physical world. At the center of all this really is mapping, right?
So digital advertising here, you don't mean the billboards and then localizing.
No, digital meaning where you have it online and yeah, right. At the center of location-based, exactly. Right. And I'll talk about all of these areas, in the deck as well. So at the core of it is mapping. There's a set of core data that powers a lot of these applications. Each of these applications might have different requirements in terms of what subset of the data it needs to look at, what accuracy requirements they might have, and so on and so forth. Right. So the narrative of this talk can roughly be divided into two parts. One aspect of it could be how has mapping technology been evolving in the last several years, and where is that going? The second really is evolution of applications. What are the new applications that are coming on board which are pushing the state of the art in mapping? And I'll try and cover both of these areas. Again, it's going to be a small cut of it. This area is much bigger than what I can cover in the next 15 minutes, but hopefully it'll give you a flavor of what's entailed here. But first, what is a map, right? So if you ask what really a map is, you can look at it as being like a layer cake, right, where you have different layers. And very coarsely speaking, there's about 3 or 4 broad layers. You have the politicals and orientation, right? You have the network, and then you have the places of the POIs. And the politicals really are your country boundaries, your state boundaries, your zip codes, and so on and so forth. Right? This is basically the table stakes of what a map really is. A level up, the network is your fundamental road network. What kind of road geometry do you have? What kinds of roads are they? Are they freeways? Are they side roads, and so on and so forth? Are there traffic lights there? Are there stop signs? A level up, you're looking at points, you're looking at businesses, you're looking at places of interest. You're looking at what's called geocodes in the industry. A geocode is something most of us take for granted, but in the mapping industry is very hard to get right, which is like, if I type in an address, 123 Main Street, where in the world is that located? The exact lat long of that, right? That is incredibly hard to get right? And this is one of those big areas where a lot of folks spend a lot of time trying to get right. So jumping into the evolution of mapping technology, people have been trying to do mapping for a very long time, right? I think this whole thing in the US at least began sometime in the 1880s when the USGS was set up to begin the systematic topographic mapping of the United States. This was an extremely manual effort. People were physically sent out to start surveying the physical area, and there was another person who would actually then sketch based on what this person was saying, right? But they went amazingly far with this approach, right? And a lot has happened since then to the late 20th century, but I won't go into all of that stuff. I will fast forward to the beginning of the 21st century where a lot of things changed, fundamentally because those things launched, right? Satellite imagery began becoming plentifully available. Companies like Digital Globe and GeoEye launched satellite that for the first time allowed a wide swath of the country and the world to be accessible to people to see from the space, right? And this really ushered in a new era of map making as well as consumer interest in the space. Around 2003 or 2004, there was a company called Keyhole that was eventually acquired by Google, which became Google Earth, which for the first time let users, consumers on the road, just see what the world looked like from space, right? And I don't know if you guys remember this, but I was a grad student back then, and I spent hours doing this. It was a complete time suck, right? So, but this is the consumer side of things. A lot more is happening on the mapping side. The same data can obviously be used for mapping, right? So you take a satellite picture like that, and you start tracing stuff on that. You start tracing your roads. You start tracing your lane geometry. You start tracing all of these things that you can see from space, right? And then suddenly you have a map, right? And what that lets you do is it lets you capture coarse base map features. These are things that you can see at that scale. It was not very fine-tuned. So you can look at roads, road type. You can look at lane information. You can see building geometry. What is the building shaped like? You can look at parking structures and so on, right? To some extent, what has been happening in the last several years is that because this data is so plentifully available, and because it is relatively straightforward to start labeling and tracing over this data, among all of the different map data providers, this set of data is more or less, I would say, commoditized, right? You can't really separate out between different providers. The road network itself is, for the most part, people have got that, right? Now, of course, if a brand new road gets constructed, there might be a latency in how quickly they catch up, but for the most part, this is I would say, caught up by a lot of folks. The place where it gets tricky is street-level features, right? So the next aspect, going a level deeper, is basically street-level imagery. Any serious map data provider has one of these vehicles running around, right? And the most popular one of them, obviously, as you know, is Google Street View, where you have millions of miles of data where they've driven the car physically and captured pictures from the street level. Right? What this lets you do is it lets you capture finer-grained information about the world. So it's not just enough to see the road geometry. You want to know how the roads interconnect to each other, right? Can I take a left turn from here? Or is the right turn prohibited? Is that a one-way street? These kind of things are almost impossible to infer by just looking at a satellite picture, right? So street names, businesses, geocodes, again, street numbers. So with street numbers, if you know 1, 2, 3 main streets on this street and 1, 2, 3 is at this location here, you can infer that that's the lat long of that, right? Now, of course, the downside of this is that the coverage and refresh are very expensive. Driving a car dedicated to mapping all over the world and then doing it again multiple times, is not cheap, right? It comes at a cost. Furthermore, this is a huge amount of data, right? Typically, mapping is done, using human workforce who actually stares at these pictures and tries to annotate them to actually build the map. With this data, the amount of information is so large, it gets extremely hard even for human ops to keep up.
So how about crowdsourcing this?
Yes, I'm glad you brought that. Yes, crowdsourcing is definitely a possibility. The reason I'm hesitating is because there was a slide on my deck that I moved out to the back that actually answers that question. I'll bring it back up, actually. Let's talk about that. So yes, it's very labor intensive. The third piece really is that you need human operations. Most of map data will need a fairly non-trivial amount of human operations. Again, large companies that do mapping have on order of hundreds or thousands of people who are annotating data, who are labeling information, and who are basically building the map state information, right? And of course, there's a whole point of trying to manage this whole operations. That itself is challenging. But now, what about automation? So the automation, a lot of advances have happened in the last several years that lets you take imagery, detect objects in them, and then be able to infer, what you see, and then try to build a map, right? Especially with the advent of deep neural networks, it has, at least with respect to computer vision, simple objects it has become fairly straightforward to actually detect them. The hard piece is that even if you do this, the bar for automation to actually go into a map is actually very, very high. With map making, there's really no room for error. If you say it's a one-way street, it better be a one-way street, right? Because the cost of a person going the wrong way is actually extremely high, right? So there still is some element of human moderation that comes into play. And there's a couple of papers that are highlighted here of the work that we did when I was at Google. And again, this is not to say that these are the only 2 papers that advance the state of the art. There's a lot of work here. This is the stuff that we talked about publicly, that's published work. So the idea here really with this one here was that we actually parsed Street View pixels and found street numbers, right? And once you have the street numbers, because the Street View car is well localized, you know exactly where that number is located, and that helps you get a geocode of that exact location. And this is completely non-trivial because now you have an algorithm that is able to do this at scale across pretty much anywhere you have street level imagery. The same thing here, in this thing, what you're seeing really is that we were able to identify the extent of a storefront. What is the extent of a business storefront? Read the title of that business and then be able to create a business listing out of that, right? So again, very, very hard. In fact, it was very difficult even for humans to say exactly what is the extent of a storefront because it's not very well defined, right? Again, lots of advances here. Crowdsourcing, you brought it up. So again, if you can crowdsource something, you should crowdsource it, right? Because that is significantly cheaper and more accessible than trying to do this using your own in-house operators. I'd mentioned reCAPTCHA earlier. So reCAPTCHA, as you know, is one of those things where you could actually leverage that from the crowdsourcing angle as well, because some information there is known, others is not known, and that unknown piece is what you could use to label. So that was the piece that also helped quite a bit on this one.
I think that the generic view of crowdsourcing is that you get some people to go, mechanical Turk style.
Yes.
But it's also the other way. When I was working in the transportation sort of space, it is imagine that everybody starts ordering online.
Yeah.
Amazon, Walmart, somewhere, okay. Let's face it, Right. And the deliveries begin to happen. It's in my interest to give you the exact lat long of my address and so annotate my location on the map. This is a straightforward incentive, including things like, the entry security numbers for the building, where to park. That is actually very hard to get, but I'm self-interested in doing this. That's right. I think that needs to be somehow explored more. I mean, entities like Lyft and Uber have, people can tell you how to get there.
So I think I would make a distinction between, I would say, what you're talking about here, where people they want a service and they're kind of giving data back for that space, versus people who are doing it for a specific cause, where they're either getting paid or they're doing it in that case, right? So when people are
UPS actually spend a lot of effort utilizing their drivers to get locations of loading.
Yes. That leads us to this user-generated content, right? So this is another big aspect of things, right? So the thing is, what we saw earlier was you have lots and lots of imagery data, you parse that, you extract information from that, and then you build maps out of that. But that has limitations. The biggest limitation is actually refresh. It's not going to be super fresh. You cannot drive and you cannot fly a satellite all the time or frequently enough. But the other aspect is that what if you could get your users to come contribute data back to you? My map is broken here, right? There isn't, this roadway is not even there. Let's go and actually put that in, right? So if you're able to get users to directly engage with your product and contribute data back, then and you're able to make it sustainable, that's when you get significant impact. In fact, this can actually span multiple types of, you could have a very sophisticated user who's able to actually go in and edit road networks, make them interconnected, and do a great job there. Or you might have a user who can just answer a yes/no question, right? Is there a wheelchair accessible entrance to the restaurant? Yes or no, right? So there's a range of what they can do in that space, right? And there's also passive and active UGC. Passive means that as you're walking around with your phone, your phone is emitting a GPS signal, and if there's a road where nobody seems to go on, that road is probably blocked, right? So that's a passive inference you can make based off of that. Versus actively, you actually ask them, is the road blocked or not? Right? OpenStreetMaps is a very interesting product where this has been pretty much entirely built off of data that people have contributed, have donated back to them, right? Where they've actually physically tried to label this stuff. They've got over 4 million users, 45,000 monthly actives, and millions of edits that come in every day. And this is entirely free, right? People can use that. Of course, the problem here really is that spam can be a problem. People can willingly go and try to add bad stuff to your data, and so moderation is also actually a critical part of this. So that was the tech piece of it. So the real message here is that tech is advancing to a point where machine learning is making a big impact here, right? What used to be what you could do with human ops, you can do with machines. And the second piece is where users are getting a lot more engaged with the products and using that to give data back. Now with applications, let's talk a bit about ride sharing, right? So with ride sharing, the key problem really is to get people from point A to point B, right? What the needs here from the product perspective really are, first of all, you need to understand what A and B are. In fact, you need to also understand where I need to go pick up a person and where I need to go drop that person off. So it's not just enough to know where the business is, right? You need to be able to compute accurate ETAs. How long will all of these drivers take to get to go and come pick this one person up? Because that's what really helps you decide the optimal driver, right? You need to be able to meter accurately. This is the first time where you don't have a physical meter attached to the car, but you're simply using the GPS from the phone to calculate what is the distance and what compute traveled, right? And of course, you have to navigate efficiently. You need to understand how people, how to route so you can match multiple passengers together. So a number of challenges here. You need to make sure the geocodes are correct. You need to understand traffic. You need to have accurate GPS, or at least be able to work around the errors in accurate GPS, and of course, have accurate maps data. On the autonomous side, it gets a lot more complicated, right? Here, first of all, a map really is simply a pre-computed understanding of the world, right? So instead of trying to figure everything out on the fly, you pre-compute that and put that in the car, and the car uses that to actually navigate the world, right? So this is really maps for robots. And here, really, what you're looking at is that you need to very precisely localize the car in the real world. And once localized, you need to have a very deep understanding of how the lanes interconnect, how the roads flow, what exactly the car has to do in the static world. So this image here really is a point cloud using LiDAR that lets the car understand exactly where you are with about 5 centimeters accuracy, right? And then this picture here kind of gives you a sense of how complex the road networks can be with the lanes and how they interconnected to each other, so the cars can then navigate them. So, and of course, the big challenge here really is to be able to automate this stuff. The eventual goal with autonomous vehicles is not to actually build maps all the time, rather actually have the car be smart enough to almost build a map on the fly, to be able to understand what it sees, just like a human driver, and have a course level navigation, but the car then is smart enough to figure out what it needs to do when it encounters obstacles. With augmented reality, another application where you need to have a much more deeper understanding of the world, the point really is that this only works if you're able to localize your phone or whatever device with 6 degrees of freedom. You need to know lat-long elevation, and you need to know your pitch and roll, right? Once you know this, you can place your Pikachu wherever you want in that scene, right? And so the problem obviously here is that how do you localize so precisely? And people have been using this visual SLAM for a very long time, and that has been evolving, but there's still accuracy issues with that. And there's obviously the operational complexity of building that map in the first place.
Sorry, well, what are we looking at there just to...
So what you're looking at here is actually very similar to this point cloud I showed in the previous one. The difference is that this is coming from a LiDAR, where you actually shoot a laser, bounce and get back. While here, what you're doing is, because you have only a camera sensor, you do a visual, you pick a feature point, camera moves, you do a triangulation, get the 3D point. So it's similar, but it's coming from a different way. There's different error characteristics around those points. With drones, autonomous drones, again, the point is you need a 3D map of the scene so you can navigate properly. You need a similar localization that was there in the AR example. And so again, the same issues of visual SLAM apply here as well. And the last thing is advertising, right? So here, again, the idea is that there was a big move going from physical ads to digital ads, where we could, for the first time, measure when people click on the ad. But what's happening now is that we can actually also measure in-store visits. So I've clicked on a link and actually physically go to the store. Problem with that is GPS is extremely bad, right? And so there's a lot of noise there, but to be able to parse it well, you need to understand what is the geometry of the building, where are the businesses located exactly there, so when people go there, you're able to filter against that, right? And so this could, again, if properly solved, could unlock a lot of value in this chain. So this is a very quick overview of two things. One of the mapping technology itself, how it's evolving, and to the applications that are actually powering, that are actually using mapping, and going back, they're giving very unique requirements back to the tech stack so it can move forward, right? If done right, mapping out here could potentially unlock on the order of several, possibly hundreds of billions worth of value to all of these companies here. Thank you.
Maybe a quick question while Seth gets himself set up.
What about using drones for street view?
What about it?
I mean, this is don't have to have somebody driving around.
Well, if it's autonomous, probably yes. But that's the same question about autonomous cars as well, right? Yeah. Yes.
How much is something you have to do once in your lifetime or Lyft's lifetime, because the streets don't change very often, and how much is sort of traffic and situation dependent that you have to keep updating?
Surprisingly, a lot of it changes over time, including roads and what you think would not change a lot. So in general, I think because the thing is, lanes are regularly closed. Roads, actually, physical roads are closed. So although you might have an understanding of the underlying structure, your actual operation on that will be impacted, right? So it's not like, I have this road once and it's going to stay open all the time. That doesn't necessarily exist.
When roads are changed like that, there's a city or someone who's doing the lane
Right.
closures. So like with GTFS, Google encouraged the cities to provide real-time updates on their service disruptions.
Yeah.
Would the same thing happen with mapping? Can you persuade cities to provide real-time updates?
It's very hard. It's very hard, right? So for different cities will have different degrees of sophistication with respect to how they provide data. And even when they do that, it's not consistent, it's not timely, it's extremely hard to rely specifically on the cities. In an ideal world, yes, but in practice, that's not what happens.
I don't have a question. You don't have to answer the question, but I want to make a comment.
Sure.
You worked at Google Maps, now you're working at Lyft Maps. Yeah. Is the future going to be that Lyft and Uber are going to just eat Google's lunch and Google is just out? Because you guys have all these vehicles roaming around.
Right.
to be discussed in the.
Sounds good.
Great. Okay, thank you very much again.
Mine?
So next is